Let me first introduce myself. My name is Paul Winchester. I'm a senior consultant here at Somerford Associates. I focus primarily in the ITOps space. I've been working with Splunk for a little over 4 years now. And yeah, observability has come up in the last 6 months or so. It's a really interesting area, covers a lot of ground, and we'll go through that in some detail this afternoon. Just a quick housekeeping point. If you have any questions as we go along, could I ask you to put them in the questions channel or the chat, and I will look through them at the end, and I'll answer the questions at the end to make sure I can get through all that we've got to go through, because we're going to be throwing some demonstrations in as well as the presentation. So live demonstration, we all know how that goes. Okay, so first I have to do the forward-looking statement piece. Before we begin, I just want to quickly note that we'll be talking about products and features that may become available in the future. You should base your purchasing decisions on the most current available technology. Okay, with that out of the way, let us make a start. So the purpose of this session is to talk about the general direction IT is moving, consider the challenges that presents, discuss the solutions, and of course, enjoy a nice cup of tea. So what's changing in IT? Well, we're pushing more and more into the cloud. And where that was once more of a niche activity, now really it's a core consideration for more or less every business out there. The reasons for that, well, first up, costs. Reduce the cost of running your infrastructure by putting it in the cloud. From a security perspective, you can reduce the risks and cost of security breaches. Cloud also gives you more agility, right? More flexibility. You can reduce time to market for new products and services. And that's a big advantage of working in the cloud, and also big reasons for the challenges. And we can't get past the last 18 months and the impact of the pandemic. That has accelerated a lot of the programs that businesses have been undertaking in terms of their cloud strategy. So yeah, lots of good reasons. So what does that actually involve? Well, in the first instance, you might look at infrastructure as a service, okay, looking at to reduce cost of infrastructure by only using infrastructure or paying for infrastructure that you're actually using. And after that, the next step might be to start refactoring your applications, integrating with software as a service solutions, and looking at containerizations. And as that evolves and continues, then you might be starting to look at being more cloud native, designing applications specifically to leverage the advantages and tool sets available in the cloud. Cloud native design using microservices and orchestration technologies to manage it all. So what challenges does this provide us with? Well, it's all, the promise is there, right? The opportunities are there, and the reality is that executing it and really getting the most from it provides some real problems, some real challenges. And the impact of that, well, if this isn't done optimally, if this isn't done ideally, you might experience more frequent customer impacting outages, with the business impact being decreased customer experience, user experience, and we'll talk about user experience quite a bit. Incident response. All this complexity does lead to a problem of, well, how do you determine what your root cause is? Ineffective incident response leads to your inability to meet your business KPIs. You might be violating SLAs that you've got with customers, partners. Other pain points, overages, okay, overutilization of your infrastructure. Is that, one of the benefits of cloud infrastructure is savings of cost, but it can go the other way too. If you've got environments that are not running efficiently, they can chew up resources. If your deployment frequency is too slow and developer productivity isn't good, then the impact of that is you're not going to be able to keep up with competition, and you'll have an unproductive and unhappy team. developers are now a key asset to any business. If they're unproductive and unhappy, you may start to lose them, and that then makes the situation even worse. So those are the challenges, those are the reasons why we are focusing much more on cloud. How is Splunk helping us to address those challenges? Well, we're going to take a look at the Observability Suite, a collection of tools that are going to help address all of those problems. So, what is the Observability Suite? It consists currently of around 6 tools. Splunk Infrastructure Monitoring, exactly what it sounds like. Okay, a tool to allow you to be able to monitor not just your cloud environment, but also your on-prem environment. We've got Splunk APM, Application Performance Monitoring, looking at how your applications are running, how effective they are, what errors or problems you might have in there. Key tool in that space. And building on that, you've got Splunk RUM, Real User Monitoring, allowing you to track individual journeys through your systems. And complementing that, Splunk Synthetics. Okay, synthetic monitoring. This tool is a more recent addition. It's previously called Rigor. Synthetic monitoring allows you to simulate user activity, set baselines, test your applications. But also built into that is optimization checking as well. So we'll go into each of these in more detail. The two at the bottom here, we've got the Log Observer. That's based on Splunk's core enterprise technology, collecting log data and providing those events for you to view in the context of everything else here. And the final piece of the puzzle is Splunk On-Call. It helps you manage your incident response, take your alerts, and actually send them to the right people at the right time so they can identify problems quickly and resolve incidents. So I'm going to do a little demonstration now. So cross our fingers and hope this behaves itself. I switch over here. Good. So this is what it looks like, the Observability Cloud Observability Suite. You can see the tools we're discussing listed here, and the menu down the side also echoes that, Infrastructure APM. So access to all of those tools from here, and we're talking about data dashboards and Darjeeling, so let's talk a little bit about dashboards first. This is the dashboard that you would see for your team. Okay, I'm in a team I've set up called Demo. You can see I've created a dashboard for the team. Usually this dashboard would have lots of this dashboard or this screen would have lots of dashboards in it. You can also set up detectors. I'm going to touch on those briefly. I should say, for a full demonstration, that's something that we can talk about, and I'll mention that at the end. But this is where your team would see the dashboards that are relevant to them. If I click on all dashboards, we can have a look at the whole organization's dashboards, and you can see a lot of pre-built dashboards already available. And the other thing I want to mention here is data setup. You can see here we currently have 140 predefined data setup options with all sort of core technologies you would expect. But AWS, GCP, and Azure, all of the main cloud platforms are integrated fully with Splunk Observability. Notification services, you've got the likes of Splunk On-Call, which we talked about before, Jira, Microsoft Teams, ServiceNow, Slack. Lots of options here, ready to go out of the box. This gives you a starting point for any one of these technologies that you want to integrate with. Gives you a really quick path to value, if you like. So that's an overview. Let me drop back to the home page and back to the presentation. So that's a quick look at the tool itself. Let's just take a step back from that for a moment and talk about what we actually mean by observability. It's a term that's getting used quite heavily at the moment. It's not something that's always very clearly defined, but let's talk about it in the context of the observability suite. So at its most fundamental, observability is being able to see what a system is doing. And generally in observability, we talk about three key types of information that we want to gather, key types of data: metrics, traces, and logs. And broadly, metrics tell you that you have a problem. Like a particular metric breaches a threshold, you've got an issue. The traces within your application and spans will tell you where in the system you've got a problem. And the logs, the events in your logs, will give you the messages, the information you need to determine what the problem is. That's, broadly speaking, how we look at it. So observable systems enable you to understand system behavior so you can more easily navigate from the effects to the cause. So that key thing we always talk about, mean time to resolve. How do we home in on the problem as quickly as possible and get MTTR down to an absolute minimum? I've heard a few people suggest that observability is just another name for monitoring. It's not entirely true. Observability builds on monitoring. You have to have monitoring in place in order to be able to do what we might call observability, or have a system that is observable. But there are a few key differences. Observability focuses more on unforeseen problems, or rather gives you the ability to look at unforeseen problems versus more predictable failures. If you know that a disk is going to fail if it gets to 95% or about to fail at 95% capacity, that's a known problem. But with complex interactions that the sorts of services that we're looking at have, there may be unforeseen consequences of changes that can't be simulated, and we still need to be able to troubleshoot. Another thing that we can do with observability that goes beyond monitoring is looking for deviation from optimal performance versus deviation from thresholds. And that generally involves some sort of machine learning or that type of analytics to be able to do that. We'll talk about that more in a bit. Dynamic systems versus predefined systems kind of ties in with that as well. That's where we see observability as being slightly different to monitoring. But both require accurate context-based alerting. There's no point in having a system that's observable or well monitored or anything if your alerting strategy doesn't tie in with it and lead to the root cause as quickly as possible. Both are effective. We need both. We need both observability and monitoring. Okay, so key use cases then for Splunk Observability. First up, cloud migration. Okay, moving applications, moving infrastructure into the cloud. Splunk Observability can help do that seamlessly, no downtime or disruption, and help with the process of optimizing cloud costs and resource utilization. For cloud monitoring or cloud infrastructure monitoring, you get, as I showed, there are hundreds of cloud integrations ready out of the box. That delivers fast time to value. The cloud integrations allow us to then manage real-time accurate alerting and monitoring containers as well, Kubernetes, on any cloud platform. As I mentioned, as you saw there, you had AWS, you had GCP, you had Azure, they're all covered. Moving on then to application performance monitoring, APM. No data is sampled when we bring the information in from applications. Every trace and every span is retained. We also allow unlimited dimensions on that data. And that gives us the ability to monitor and troubleshoot these complex microservice-based systems. And the final use case I've got here, and of course there are many more, but incident response. We talked a little bit about that with On-Call. Incident management is a key part of the game here. And what we can do with Observability Suite is connect SMEs to the data they need to significantly reduce mean time to acknowledge and mean time to resolve. Okay, enough of that. Let's actually get stuck into it a bit more. We'll go in a bit more depth about each one of these tools. So what I'm going to do is a short demonstration of the infrastructure monitoring and APM tools. We're not going to have time on this session to look further than that, but I want to give you a taste of what those, how those operate. They're the kind of two, if you like, the two first tools that we're going to be using. And then I'm going to give the breakdown of each of the others, a bit of an explanation before we round this off. So let's switch back to the demo again. Back to the home screen. So if we go into infrastructure down here, you can see that we have, I've run up a couple of EC2 instances for this demo. So you can see that we've got 3 here. Let's click on that. Okay, 1, 2, 3, and you can see that one is called demo, and then today's date PW. So that one's mine, and I've got test 2 and test 1. So I click on my one here. We can see what that EC2 instance is up to, CPU, memory, all the things you'd expect to see. And there is a lot of information here to look at and review and analyze and potentially alert on. So you see the little bell here, that allows us to create an alert, or what they call in the observability a detector, to drive an alert based on this particular metric. Really quick and easy to set up. Now, if we have a look at dashboards again, and go to the all dashboard list. Down here we see host with agents installed. Let's have a look at that one. Okay, so you can see we've got 4 active hosts. It's going to give you some aggregated values here, some average values here. And if we want to look at a specific one, let's have a look at my one, for example, which I know is called that. Again, I'm now looking at my specific environment there. So again, these dashboards come out of the box and can be expanded on, adjusted as needed, really quickly, really simply. It doesn't require a huge amount of training or whatever to set this up. Okay, let's have a look at one more while we're in infrastructure. We talked about Kubernetes. We talked about these clustered environments. So here are my 3 test clusters, and this one is my one. So we can drill down into that and have a closer look. Gives you all the different pods, shows you what's going on. We've got a red one here, what's happening there. Okay, that one's not ready, fair enough. And across the top here, we can see types of information you might want to drill down on. Okay, what's actually going on in there? What does the workload look like? So, real whistle-top store, but I just wanted to give you a flavor of what's in here. And honestly, this just took me a few minutes to set up. Just, you know, a lot of this is just there ready to go. Obviously, you might want to go beyond it, but there's a lot there just to get started. Okay, go back to my homepage and on to APM. In some ways, I probably should have gone straight into the APM demo because that's what we're going to do next. So application performance monitoring. Yeah, let's dive straight into it. So again, I've pre-selected this one because I was working on it before, but you can see a list here of all the different environments that we may want to be taking a look at. So this is sort of screen that your site reliability engineer might want to see. A summary of everything going on across the board for this, in this case, for this particular cluster, but we can do it for all environments as well. Just have a look at the whole estate, as it were. Take a moment. But let's switch back to my one. And what you might spot here, immediately looking at this, is, hang on a second, what's going on here? The top service by error rate and the top business workflows by error rate. Well, payment services got a very high error rate here. Same showing up here. Perhaps there's something I need to investigate there. And I'll show you in a minute what that looks like if we drill down directly. But first, I want to show you the big picture. The overview of the whole service. Now, I have to stress here, I did absolutely nothing to build this service tree. That service tree is built from the data that's in the traces and spans generated by the application. From that, it works out what the service tree looks like. That means that if you change your service plan, the way your services link up, that's absolutely fine. It will get reflected in the service diagram. So the instrumentation needs to be set up to have the information necessary to build this service tree. But with that in place, this is what you'll get. So this shows how everything fits together. And hopefully it's immediately obvious that there's a problem with payment services. We saw that on the previous screen. It's highlighted here as well. And just quickly to show you what this actually indicates, that red dot shows a potential root error rate. And this is where there's a bit of machine learning built into the tool to help identify potential root cause. Okay, let's hide that again. All right, so we can see we've got a problem with payment services, or the payment service. Let's have a click on that and see. So we've got various options down here. What I'm going to do, because I know what the problem is, I'm going to cheat a bit. I'm going to click on the version, because what's happened here is we've made what's called a canary push. We've pushed out a new version, a new release. I'm going to zoom in on that so you can see it a bit better. Oops. Zoom in a bit further. And version 9.9 is still running perfectly well, nice and quick, low latency. And we can see that version 10 or 0.10, that's where all of our errors are coming from. So, okay, that's a nice, easy example of root cause analysis. But actually, yeah, it already highlighted that for us. All we had to do was drill in and identify where the problem lay. While I remember, another quick thing to show while we're here, if I just click on one of these charts, it'll give you some example traces. I stress they're taking an example, but every single one of these traces is still stored and recorded so that any user problem can be analyzed after the effect, not just in real time. I click on that, it will drill me right down to the individual traces. So that's very interesting. Another thing to point out here is this. Down here, we've got a link to the Kubernetes cluster. So we're in APM, but we've been given a link into the infrastructure monitoring. If I click on here, you can see highlighted, there's the payment service pod. Okay, that's where our problem lies. Now, we know that there isn't actually a performance issue on that pod, but that could have been the root cause, and that allows us to go directly from one to the other. Step back. These that can take more than one step back. Come on. Okay. So one other thing to highlight while we're here before we move on, the tag spotlight. Okay, this is another way of cutting and slicing the data in order to identify root cause. Okay, we know what the problem is. We know that the problem is with the version. So that is a payment service, yeah. And you can see down here the version, all 129 errors have been identified as potential root cause, and all 129 are impacting this version. Now, if I have a look at a few of the others here, you can say, right, what about the tenant level? Well, our gold, silver, and bronze level tenants are all equally impacted by this. So that's not root cause, for example. So a really useful tool, as far as I'm aware, that's unique to the Observability Suite, the Splunk APM. Yeah, a really powerful tool to use in this situation. All right. So anything else I needed to highlight? No, that's it. Good. Yeah. So this is great. I have to say, whenever I show this and point out that it's generated from the data, that's a really powerful part of what this tool can do. Okay. So let's move back to what's next. Real user monitoring. So Splunk RUM, it builds on the same innovations and data as APM, but it's the only solution out there that's providing real-time and full fidelity visibility into every single customer or user interaction within even an application. And that really is key to it. It gives you the full fidelity end-to-end trace. So some other systems might start collecting data once enough problem's been identified, but if the problem actually started prior to an incident being identified, you haven't got that information. when it comes to coming back to do an assessment of what went wrong, what happened with this situation, it may have happened hours or even days beforehand. You need to have access to all of that data. So yeah, that gives your DevOps, your operations team, a complete end-to-end understanding of the user experience. It helps developers understand and optimize the user journey as well. So, if you can see that there's bottlenecks within your system because you can see each step and what the latency is at each step, you can look at refining that particular step in order to remove that bottleneck. So, real user monitoring, another key part of what we can offer. And then Splunk Synthetics, as I think I mentioned before, this was previously called Rigor. And again, this complements what we're trying to do with real user monitoring. It allows you to collect web performance data at any frequency from any location in the world. There are hosting arrangements in, I can't remember the number of locations, it's something like 27, 28, maybe even more than that, to allow you to simulate what a user's experience might be like from any one of those locations. Really useful for testing, but also for baselining your applications to understand how you expect them to perform when you put them into the real world, which you can then compare to what actually happens. You can trend data based on a wide variety of metrics and core web vitals. And from this, you can alert your teams and report on potential problems before they actually impact customers. So one other component of this as well is not just the synthetic monitoring, but mentioned here the web performance optimization. One of the great things you can do with it is actually see how each step, every single step of a web application loading behaves. And for example, an obvious one, maybe you've got a graphic on there that's particularly large and it's just causing a slight delay for the download, perhaps more impactful for your mobile users. Okay, and there is a suite of optimization recommendations that can be applied to your application automatically to help that optimization process. And Splunk Log Observer, I was going to say it's the final tool, but it isn't. It's the penultimate tool, Splunk Log Observer. If there's anybody here who's currently using Splunk Enterprise or is aware of Splunk Enterprise, this is a core part of the technology. It goes back now 15 more years. Splunk Log Observer is based on Splunk Cloud. So it uses Splunk Cloud behind the scenes, but as you can see, hopefully from the screenshots, a little different to Splunk that you might be using at the moment. It's puts the power of Splunk logging into the hands of those who need it, site reliability engineers and developers, giving them the tools to effectively address their specific use cases. It's cloud hosted, so customers can start in minutes and offers out-of-the-box integrations for fast time to value, much like we were seeing there with infrastructure monitoring, for example. And using the real-time streaming architecture, it provides what's called live tail, which helps users keep an eye on things in production when new code is deployed. So a live tail is vital when you're doing that canary push, just to see, is there a spike in activity, a spike in errors, a spike in messages that maybe is a result of that push. So that's Splunk Log Observer. And now the final tool, the final piece in the jigsaw, Splunk On-Call. So I'm sure everybody here has experience of managing alerting. Okay, we all know that can be a challenge. You have too many alerts. Your alerts are perhaps repeating themselves. There's too many of the same alert, or perhaps they are too many false alarms. And also, how do you inform the right person? How does the system know who to direct this alert to? Do you just alert everyone and see who picks it up? What Splunk On-Call gives you is a series of tools and means of managing all this. So firstly, you can set up a team, a group of people, and say who's on call and who's not. You can move shifts around. You can very quickly and easily manage that. You can manage escalations so that if something isn't responded to within a certain length of time, it can be escalated up to someone else and up as required. You have stakeholder notifications, as I mentioned. That's when things have to be escalated. Team views, virtual war rooms where you can bring people in and say, right, I think this needs this team, this team, this team. Go and get me the people who are on call from those teams. Let's bring them all into a room together, virtually, on a mobile app, on your laptop, whatever, and let's get this sorted out. So Splunk On-Call kind of ties together that part of the incident management challenge, and yeah, kind of rounds out the observability suite. Okay, so I was going to give you a quick example of a customer success story. Lenovo, hardware manufacturer, said that with Splunk Observability Cloud, Lenovo reduced total cost of ownership and cut troubleshooting time in half during one of the busiest sales days of the year. Well, that busy sales day was Black Friday, and this is a quote from Ben Leong. With Splunk Observability, our mean time to resolve went from 30 minutes to under 5 minutes, allowing us to maintain 100% uptime through Black Friday traffic, which was 300% higher than the previous year. Splunk Observability has greatly improved our operational efficiency, team collaboration, and troubleshooting time to ensure that we are always providing the best experience for Lenovo customers. So a pretty striking success there. Okay, so what is different about Splunk Observability compared to other tools in the market that might broadly cover the same sorts of areas? Well, as I mentioned, you get all of the data. No sample is the sort of tagline that's used, they even trademarked it. Every piece of data, every event, every trace, every span, and every metric is stored and saved for future access. That means that whatever happens, whatever the time frame, you will be able to analyze the steps that led up to an incident or indeed anything else that you might want to look at. Real-time streaming data. I mentioned the live tail on the logs. The data streaming live to the APM tool as well, and scalable. Okay, I'll give you an example of how scalable it is. Splunk used Splunk Observability to monitor their own cloud instance. That is Splunk Cloud that supports thousands of customers all around the world and provides them with a Splunk platform that is operational to, I think it's 4 nines levels of availability. That is an absolutely massive environment to monitor, and yet Splunk Observability managed it. Added to that, you've got analytics with machine learning built in. We looked at that example of the root cause indicator in APM. It's built into the product. This is not an extra tool you have to add or pay for. It is part and parcel of what Splunk Observability provides for you. And it's also open source. You might have seen, I didn't point it out, so apologies for that. You might have seen the OpenTelemetry collector mentioned on one of the screens. OpenTelemetry is the way that the information from, or traces and spans are collected from your applications, and the infrastructure metrics are collected from your infrastructure. And it's open source. Splunk is a key part of that project. It's one of the biggest projects in the open source community at the moment, I think second only to Kubernetes, which is huge. And what this gives you, what this means is that once you've instrumented your code using the OpenTelemetry standard, if for any reason you need to switch to another vendor, you don't have to re-instrument. For those that are offering proprietary tooling, if you want to make a change, you've got to redo all of that tooling. So open source is another big part of this. So what does that give you? Well, it allows you to improve customer experience, improve your release quality and velocity, improve developer efficiency, and improve your business's adaptability and flexibility. So how can Somerford help with all this? Well, firstly, I mentioned that we can go into this deeper. It's actually on the next slide, but I run a workshop that goes into this in more depth. We can do a demonstration that goes beyond the very brief look you had now. There are more webinars that are planned, so please get in touch if you're interested in going into more depth. This webinar is sort of designed as an overview. We're going to go into more depth in particular areas in future webinars. Somerford is an elite Splunk partner. I believe we have the largest PS team in the UK. In fact, I think I was hearing that it's actually bigger than Splunk's own PS team. But anyway, we have a large, fully qualified Splunk PS team, and with very broad experience. Obviously, when you have that many people, we have experience in lots of different industries, lots of different tools. So I'm sure there's something we can help with there. So yeah, please give us a call. Make yourself a nice cup of tea. Hopefully the Darjeeling is going down well. And I think one final one here. Yep, just talking a little bit more about that observability workshop. That'll be run by myself. As I mentioned at the start, certified consultant with Splunk. And it's a dedicated workshop taking you through Splunk Observability. It's hands-on, so you'll get to create dashboards and drill down into the service tree and all the rest of it. With the environments that you saw me demonstrating on, we spin up as many of those as we need for each person who wants to get stuck into it. And that'll help you gain a deeper understanding of Splunk's Observability Suite. So thank you very much for your time. I really appreciate you joining me today. I really hope that's been helpful. And if there are any questions, let me just see if there were any in here. Okay, we have one. Can you tell me a bit more about the tooling integration? How would one monitor a Java microservice stack? Okay, that's a really good question. It's a very specific one. I don't have an immediate answer to. So in terms of the integrations, that depends on what the integration is. So the great thing about that screen I showed you, in fact, let's just jump back onto it, because I think this is something that perhaps doesn't get emphasized enough when talking about observability. How to behave. Let's go back into this data setup. What each of these gives you is instructions on how to go about it. Now, I'm going to be honest, some of the instructions are obviously better than others, but really the ones that we've tried from some of the key technologies that we're interested in have been really good in terms of what steps you need to take in order to set it up. So if, for example, you're interested in Java microservices, I can look into that. We can take a look and see how that would work, and come back to you and explain what those steps would be. A lot of it's documented here, but this is not comprehensive. This is just what is fully documented and made available, as I say, out of the box. So yeah, so the answer to your question is that integration process will depend on what you're integrating with. But what this provides is the steps that you need in order to do that. And our guys, our engineers who've been playing around with this, have generally found that they can follow the instructions. They don't necessarily have to be an expert in the technology they're linking up with even. They can follow the instructions and get something working. So yeah, it's pretty good. Some are stronger than others, but yeah, it's pretty good. So hopefully that answers that question. That's the only question I have on there. So Lewis, I don't know if there's anything else I need to cover at this stage, but I feel like that's probably covered everything. Let me just drop back onto here. Yeah. So thank you again, everyone, for your time this afternoon. Please do get in touch if you want to go into any more depth on this. I'm more than happy to, let's say, fire up one of these environments, take you through it in more detail. We can look at some of the specifics as we go through. And if you want to organize a workshop or a demonstration, please contact your contact at Somerford. But I think that's everything. So thank you again, and I will catch you in the next one.